Hi everyone, I hope you all are doing great. We are starting a new series of Kubernetes projects and deploy it in our infrastructures. So this series is going to be very interesting series because whatever we do implement in our organizations, we are going to replicate the same setup using Kubernetes into our machines. Now you might have a question in your mind, how the Kubernetes cluster I will be running. So in our Linux machine, I'm going to use a kind cluster. Kind is a type of tools which uses Docker as a backend and then it deploys multi-node cluster. To be honest, this is going to be 100% real time, which you do in companies. In companies, you set up your Kubernetes on Linux box using kubeadm or even set up it manually, or many other tools are available. So in this project, you will not feel any difference between the real-time clusters and the Linux machine where I'm using the kind cluster. So please follow us each and every line of the project, and it's really going to make sure that you are going to be expert of Kubernetes after going through this complete series of projects. So let us begin. First, I'm going to deploy the kind cluster. Then I'm going to create 3 node kind cluster and then deploy the Nginx applications and then understand how kind works. So let us begin. I have a Linux machine and how to confirm, you can check here uname-a and you can see this is a Linux machine and this is kernel version 5.1, 5.167. This is the details and this is Ubuntu. How I can check that? Cat etc star release, and you can even see which version of Ubuntu. So it's one of the latest version of Ubuntu 24.04. So now how I'll do the kind setup, let us follow me step by step. So I hope you can see these all steps which I am going to implement. So first, why kind? Kind stands for Kubernetes in Docker, and it is a tool designed to run Kubernetes cluster locally using Docker container as nodes. Second thing it is a lightweight software. It runs on Kubernetes cluster inside Docker containers. So you don't need to set up a virtual machine or actual physical nodes. Next benefit is it is very fast to set up. So it allows you to create a Kubernetes cluster in minutes. You can simulate multi-node cluster. So you can simulate multi-node cluster with control plane and worker nodes. So let me explain how it works in Kubernetes. So in Kubernetes, you will have multiple nodes in your clusters. Suppose I have 3 nodes. One node I'm making it as a master, you can say, or we can say it as a control plane. So this will be our control plane, and then worker 1, and then worker 2. So one master and 2 worker node. And this setup we are going to replicate using kind. So kind will be used to set up this cluster. Now, next is it's great for local testing of Kubernetes resources. You can validate Helm charts, running Kubernetes related, all the stuff in Kubernetes. Almost you can do using this setup. And kind can help you to create multiple versions of Kubernetes clusters. So even you can use it to test or do the POC on multiple Kubernetes versions. So first thing is how it can be done. So first thing what you have to do, you have to just search kind setup for Linux. And if you click on this, and if you go on the installation options, you will see here for the Linux x86-64 AMD or ARM. My system, if you go here, you can see it is x86-64. How to confirm? So here if you see x86 64. So you can use this to set up. I have already downloaded this, so it's not needed. Otherwise, you can download and you can install in your system. Now, once this is done, so if I type kind command, you can see kind is there in my system. So I already downloaded this. But still, clusters are not ready. So let us create the kind cluster together. So what I have done, I have installed kind already. Now, with kind, you can specify which version of Kubernetes you want to do. So here I have specified 1.24 and 2 worker nodes. I have created a kind config.yml file. So first let us go in the system, cd, mount in C drive, and then I have users, this, then desktop, then Kubernetes, and then here DEVOPS-TECHSTACK, and then Kubernetes k8s project. And here if you go, so this is going to be our day one of project. So let us see, here I have created the kind config also. So go to day one, and here we have a kind configurations stored here. So open vim kind config.yml. So see, first thing is kind cluster API version. This is the API version. Then name I have given DevOps Tech Stack cluster. You can name whatever the name you want. And then node, one node is control plane, and here image of kind, then worker node and image, and then the worker node and the image. So there are two workers, and there are two workers, and then one master node. Now, once you see this, how to create it now? So to create this, we have a command, and that command is called kind create cluster, and then you can specify the configuration file. I have explained you the configuration file already. So now just kind create cluster, and then your config file name kind config.yml. So once you start, you can see it has started preparing the node. It will take few minutes to get the cluster ready. Meanwhile, let us understand it further. So once our clusters are ready, you need a kubectl. Why kubectl? kubectl is a tool or a command line tool which helps you to interact to your Kubernetes cluster. So it interacts to the kube API server and it gives you all the details. So kubectl needs to be installed in your Linux box. You can install kubectl. So directly go to internet and just type kubectl for Linux. Once you go here, you can see using curl on Linux, and here x86 64, directly it will download, and then we have to move to the path. In my case, I have already kubectl here. Now here you see kind cluster, ensuring node image, preparing the node, writing configuration, starting control plane, all the networking ready, storage is ready, and joining of worker nodes. So everything is done. Now you can see the cluster info using this command, which is by default printed here. And if you want to see, here you can see. So Kubernetes control plane is running at this. Then core DNS. Core DNS is for the DNS management in Kubernetes cluster. And then you can see, okay, your cluster is running. Now, as I told you, using the kubectl command, so kubectl get nodes, and you can see the nodes are ready. So here you see one control plane and two worker nodes are ready. Now, since I don't want to type kubectl each and every time, because I want to use a alias name. So in Linux, you can use this alias concept using In Linux, you can use this alias, mm, and this alias instead of kubectl, you can type a name which you want to use. So I have modified my bash profile already. And in my bash profile, I have already entered. So kubectl is now written like KC. So from going forward, instead of using kubectl, I will be using KC command. And this KC as a alias I have put in my bash RC profile. So if you go to bash RC profile, anywhere you can just put alias like this. So how to put like this way you can see multiple alias. Similar way, let us put for the kubectl also we can put. So let us put here only alias kc is equal to kubectl. And once this is done, then you have to do load this file. So source and then bash rc. And then if you see kc get nodes, you can see. So instead of kubectl, kc also you can work. And you can see your nodes are now ready. So one control plane and two worker nodes. Now let us move next. So in case you want to delete the cluster, you can just put cube instead of kubectl here because it's a kind cluster. So kind delete cluster and name DEVOPS-TECHSTACK cluster. So this will delete it. Now to get a project right now running in this system, what we have to do, we have to go to the path where all configurations I have stored. So now let me explain you what it is. So I have a Docker file here. Let us see what is in the Docker file. So just I am using from Nginx latest. So latest image of Nginx I am downloading from the official Docker Hub, and then I am copying the index.html file inside the container. So user share nginx html and index.html. So whatever the content will be in this index.html, whenever you will expose these applications and open it in a browser, it will be visible to you. So just save it. And then what I have to do, I have to go and build the Docker file. So Docker build -t, and then I am giving the name as kind nginx custom. So Control C, go here, just paste it, and you see image building process has been started. So now your image is ready, and if you see Docker images, you will see kind nginx custom. 5 seconds ago this image is ready. Now you can verify, already we have verified. So again you want to see, just see Docker images and then pipe symbol kind. So you see kind nginx custom, it's 19 seconds ago, it's ready. Now see, right now we are not directly interacting, which means in our deployment of Kubernetes, we can download the images which is stored in Docker Hub or in our private artifactories. But in our case right now, I just want to load this image to each node in the kind cluster manually, because in coming projects, I'll show you how to directly use the public repository or private repository inside the Kubernetes configurations. But as of now, what I want to do, I want to load this image into our kind cluster. So command is kind load and then Docker image, kind image name, and then your cluster name. So once I type this, what happens? You can see a message, it started loading. So loading process is running now, and you can see loading is already done. So now once loading is done, you can create your pod and service file. But in these projects, I am going to create only pod, and services we will be learning in coming lectures. So now I have a pod definition already stored here. Let us see what is the definition of pod. So API version, when you write a configurations, you have to specify the API version. This is V1. Kind, Either it's pod, it is deployment, or it's service, or it's cron job. So type of object is pod. I have specified. Then metadata means information about this pod. So name of pod is Nginx pod. Label is app Nginx. And specifications, container name is Nginx. Image is kind Nginx custom latest. Whatever the image you want to use, but in our case, this is the image with the latest tag. And image pull policy. So by default, it will pull from the public repository, but here we have written if not present. So in this case, if the image, so image already we have loaded to our kind cluster, so it will not try to download it from public. And then port, which port you want to run, container port is port 80. So just exit this file now and do apply. So how to do? KC KC denotes kubectl. So KC apply -f and then pod.yml. So you see pod nginx pod created, KC get PO, and you will see nginx pod is running 6 seconds ago. So now once your pod is done, service we are not going to create in this lecture because pod is the smallest object in Kubernetes. So first we'll learn how exactly this is working. So once our pod is deployed, we can open our applications on port 80. But 80 is the local port. You want to open in the browser. So what we are doing? We are doing the port mapping for your pod. So pod is by default running on, if you see, pod is by default running here on this particular worker node. Now, if I want to map this port 80 to be opened in the browser, what we are doing? Port forwarding we are doing as of now. So if you go here, kubectl port forward and then your pod name. So kubectl pod forward and then our pod name is nginx pod. So here nginx pod pod. So now it's forwarding port 8080, means 8080 you can open in the browser and it's pointing to port 80. So if you do here localhost colon 8080, here you can see welcome to my custom DevOps tech stack nginx page on Kubernetes. So this is ready now. You can see your email, you can open it. And if you stop the port forwarding, you cannot open. So now you see it's refreshing, you cannot open. Again, the moment you just forward the port, it can again open in your browser. So now you can see you can open this in your browser. So I hope you guys got a clear understanding of how to deploy a pod in Kubernetes cluster, how to create a kind cluster, and then how to get or access that applications inside your browser. And in this project, few high level things which you will be learning is what is deployment in Kubernetes, how to deploy a Python Flask application in Kubernetes, and how to browse that applications, and what is exactly difference between pod and deployments. So first, if you understand pod, what is pod? A pod is the smallest and simplest unit in Kubernetes. It represents a single instance of running process. So suppose you might have a question in mind. Why I have to create deployment using pod? I can deploy my applications. Yeah, that's okay. But that pod is ephemeral. Ephemeral means pods are not durable. So if pod is deleted or crash, it is not recreated automatically unless it's managed by high level controller like deployment and replica asset. So only pod in our first project we deployed only pod. So that is fine till the time pod is not crashing. And there can be multiple reasons your pod is crashed in your system. In that case, pod cannot recover automatically. So that's why we need deployment or replica sets. Pod can contain one or more containers that share the same network namespace, storage, and lifecycle. So first thing you understood, pod is ephemeral, like pods are not durable. Next is direct management. You can create and manage pod directly, but this is not recommended for production workload because they lack self-healing and scaling capabilities. Because you cannot create multiple pods for same applications. Second, it cannot heal automatically. You need some management ways like deployments or replica sets to manage them. Even though with pod you can do things, but due to these problems like it's ephemeral, no self-healing capabilities, you are not going to use pod. So on higher level, when pods are deployed using deployments, so deployment is like a high level abstraction that manages pod and replica sets. It provides declarative update for pod and ensure that desired state of application is maintained. So deployments are used to define how pods should be created, how scaling of pods should be done, how it should be updated, and how rollback should be done. So deployments are used to manage the life cycle of pod, ensuring the desired number of replica are running and handling updates and rollbacks. So now, if you can understand more detail about deployment, it's a declarative management, means you define the desired state, like how many copy of your pod, what will be the image, and Kubernetes will make sure that those things are met. Self-healing, so if pod is crashed or deleted, deployment will automatically change or replace that pod. It can scale, so you can scale this very easily. And rolling updates and rollback, suppose sometime you need to restart your pod just for some updates or some changes in your system. It happens in the rolling fashion. Rolling fashion means inside your Kubernetes manifests or inside your deployment YML, you can define like 25% of pod only needs to be deleted when you are doing some changes. So it will be done in the rolling fashion. Like one by one pod, the changes will happen. It's not like all pod will be deleted at the same time and new pods will be created. So this is rolling update and rollbacks. So your application will not be impacted because all pods are not going down at the same time. Few pods will still be available to serve the traffic. And next is replica set management. So deployments create and manage replicas which ensure the desired number of pod replicas are running. So I hope you understood difference between pod and deployments. In today's lecture, we are going to understand how we can deploy a Python Flask applications in Kubernetes and how to browse that application as well. So let us move to our lectures directly. Let us move to our day 2 folder. And in day 2, if you go, you have first create a Python web application using Flask, then create a Docker file. So that application needs to be Dockerized. So you have to build the image based out of that Python code. And then you have to create a deployment and service. But service we will not create in this lecture. In coming lectures, we will understand about service and then we will deploy it. So now, once this is ready, then you have to deploy your applications. Now, what is the Flask applications? First, understand this. So, Flask is a framework in Python which help you to create um, UIs or websites or browsers where you can access that. So Flask is a module. So first I am doing importing Flask and a request module to handle the API request. API request is like hitting into that particular web URL. You can do get, post or put other kind of operations related to API. So first I'm importing my Flask applications in Python module. And after that, creating an instance of it. What is creating an instance? So these modules or these modules need to be initialized in your applications. So once it is initialized, and in the initialize, I am telling Flask and underscore name. Then application root we are defining. So at the rate app.root, once it is initialized, then app.root, and we are telling the root is this slash. So this slash is the root folder, like the root path. So get and post methods you are going to use get and post. And then we are telling define home is a function. And I am telling if request dot method is post, like something is getting posted, then message request dot form dot get name message request dot form dot get message, and then return hello, then your name, and then whatever the message you said, and then it will return. And from method post, we are telling name as input type is text name. So a text name will come, and then message, a text box will be there, and message input type again text, and the message you will be typing. So input type will have a submit button, and then submit, and then form is closed. So this is a normal code. And once you closed it, then you are telling if underscore underscore name underscore underscore is equal to main, then app dot run debug is true, means the code, all the errors will be displayed properly. And then host, you are allowing all the hosts, like 0.0.0.0 means all the hosts are allowed, which port you have to run the application on 5000 port. This line might seem confusing to you. Just understand on a as a layman that this says to your Python that this is not a module, this is a code which I want to run. So that's why you define this if underscore underscore name is equal to underscore underscore main. This means you are telling this is not a module, this program needs to be executed, and that's why we are doing app.run and then running on 0.0.0.0 and port is 5000. So I hope Python code is quite clear now. Now go to our Docker file. So Docker file, since it's a Python application, you need the Python software, right? So from Python 3.9-sleep, so this will be official image which will be downloaded from Docker Hub, and then working directory. What will be your work directory? Wherever you this code will be placed. So working directory is /app, and then what you are doing? You are copying dot to /app. Dot means your current directory, whatever the things are there, you are copying to /app, and then you are installing pip install flask. So inside that Python you are installing flask, and then you are exposing your application on port 5000, and then as a command you are running python and then app.py. So this code will be run, and this is the Docker file. It will build the image and it will run, expose the application on 5000 code, and it will run this app.py. Now once your image is ready, then you have to create deployment. So in pod, if you remember, we just do /v1, here app/v1, and then kind is deployment. There it was pod, here kind is deployment. Metadata is same. So metadata name is Flask app deployment. You can put any name here. And in the specification sections, you are telling how many replica of your applications. I am defining 2 or 1. It's your choice. Then selector. Selector will match the levels. Level is like you are telling app name is Flask-app. And then in the template, you are telling metadata, and in the label, your app name is Flask-app. And then here you go to a specification sections, and in this, inside the container, your app name is Flask app. So this deployment, why matching levels are done? Because this will match with this name, and then it will apply all those replica counts and other thing there. And then image is Flask app, latest image, and image pool policy if not present, and port, it will be running on 5000 port. So now first you have to build your Flask app. So Docker build -t and then Flask app dot. Dot is like the current path where my Docker file is here. So here if you see, you will see Docker file is here, right? So now if you do, first check the pods. So kc get pods, and you see one Nginx pod in the first project it's running. So nothing else is running. Now you have to build your image because Docker file is here. So from here it will read the Docker file. So see, now it is so uh, copying is done, and then pip install is done. So images is ready. So if you do Docker images, you will see Flask app 5 hours ago. Okay, so previously the images were existing. That's why you did not see the new image got created. So let us do one thing. Just remove those images. So Docker RMI and then Flask hyphen app, and then docker rmi flask hyphen app, and then again check. So again one flask app is there. So docker rmi flask app colon 0.4. So I remove this as well. So if you do docker images, now you see no flask related applications are there. So now build the image. So docker build image flask app, and maybe this time I'll put the tag also 0.5, and then run it. So now if you do docker images, you will see flask app right now with 0.5 tag is available here now. Now clear the screen, and you have to now do the deployments. But understand one thing. In the last lecture I have told you, before creating the deployment, you are specifying the image here. So image is with the latest tag here. First thing, you change the tag to 0.5. But this image is not available publicly. It's stored in your local system, and we have not published this image through any of the Artifactory or Docker Hub. So how kind cluster can find this image? So for that purpose, what you have to do, you have to load this image in the kind cluster first. So how we can do that? We can, if you remember correctly, we have a way to load those images. So how? Kind load Docker image and then your cluster name. So just copy this, go here, but your image name is different, right? So here your image name is flask hyphen app colon 0.5. This image needs to be loaded in your kind cluster. So if you see, image loading is running now. So once, yeah, now image is loaded. So once our image is loaded, now we are ready to do the deployments. So if you go here, I already explained you that we have changed the image. Now, if you save it and just go here, kc apply hyphen f, and then your deployment name is flask app deployment.yml. kc is qctl. Again, I am reiterating it. So alias we have set in our bash profile. So now if you see, deployment got created. So now if you do kc get pods, you will see two copy because we have defined two replica, and where you see two replica we have defined. So that's why two copy of your pod is running in your system. Now, what we want to do, we want to access these applications in the browser. As I explained you, these pods, right now we have not created any service, so load balancing is not going to happen. But still we can do the port forwarding for any of this pod. So how to do that? kubectl port forward, and then your port pod name, and then where. So on 8080 we are forwarding, but it's exactly pointing to port 5000. And what is 5000? 5000 is the place where your application is running. So if I do this port forwarding now, and if you go to your web browser, you can see on localhost 8080 it's running. Now suppose if name I put as DevOps Tech Stack, and a message I am telling good morning. And if I am doing the post request, so hello DevOps Tech Stack, you said good morning. So how this has worked? Because our Python applications, if you go to app.py, and here if you see in app.py, you are telling if request.method post and request.form get name. So with the form, it's getting the name and then getting the message, and then it is returning hello, your name. So whatever the name DevOps Tech Stack I type and your message. So this is returning this value, and this is a form which you are creating, and this form you see already available in the browser. So here if you see, there is a name form. So name is a text box here you see, and then message is also a text box which you see, and input type is submit. So here a button, submit button is there, and value is submit. So this form is helping you to get this, and this post request is helping you to post the message once we enter the values. So I hope you understood this Python application completely, how to create a deployment, and then how to do the pod forwarding. In this project, what will be your learning along with the project? You will learn about concepts of environment variables in Kubernetes, secrets in Kubernetes, and services in Kubernetes. Now, let us begin. First thing, secrets. What is secrets? So, secrets is designed to store sensitive information like password, API key, TLS certificates, and other confidential data. It is intended to keep sensitive data secure and separate from application code. So, is a type of Kubernetes object which stores the sensitive information. Apart from that, you have environment variables. Environment variable is used to pass configuration data like sensitive or non-sensitive to application running in containers. Typically used for non-sensitive applications like feature flags, URL, environment specific settings. So it's a kind of configuration data which you pass to your running containers. It can be non-sensitive or sensitive, but it's like a configuration kind of information. Now, if you talk about security aspects between secrets and environment variables, secrets stored securely in Kubernetes etcd database and it's encrypted at rest. To access it is restricted using role-based access control and base 64 encoded by default, not encrypted, but it's really secure. Environment variables stored in plain text within the container runtime environment. So it's in a plain text. Less secure for sensitive data because they can be exposed through logs, debugging tools, or environment inspection commands. So you understood why secrets, not environment variables, in case of sensitive data. Now, these secrets can be mounted as volumes or environment variables. Secrets can be injected into pod as environment variables for easy access by applications, or as a file mounted as volumes in the pod file system, or you can attach it, this secret, as a file. Take an example. So suppose in the environment variable you are telling DB name and value from secret key reference. Name is my secret and key is username, and then name is DB password, value from again secret key reference, secret file, name is my secrets, and key is the password. And this is referring from secret key reference means secrets file. Similar way, if it is mounted as a volume, in that you can do volume mounts, and then name is secret volume, mounting path where you are mounting, etc secrets, and read only is only true, and volume is secret volume, and secret is your secret name. So this way also you can do. Now you understood why secrets, why environment variables. Now the third concept which we have to learn today is services. Services is very important in Kubernetes world. So in Kubernetes, a service is an abstraction that defines a logical set of pod and policy for accessing them. It provides a stable endpoint IP address and DNS names for communicating with pods. Even as pods themselves are dynamically created, destroyed, and rescheduled, services enable decoupling between the front-end and back-end component of an application, ensuring reliable communications. Just take an example. So, suppose in our previous projects, we have deployed two pods of Flask applications. Like this was pod 1. So, you have P1 and then you have P2. When I was exposing the applications, I exposed for one of the pods. So, load balancing was not happening among them. So, what we do? We create a service as a abstraction layer. And now what happens that once your pods are destroyed, and if you are exposing some port, obviously the pod name will change. So that exposing again you need to do. But if you create a service, you release the level of applications, and then that level is pointing to all the pods. Now this service will point on the particular pod, pod port number, and suppose if pod 1 is deleted or pod 2 is deleted, new pods are coming like pod 1 and pod 2, no problem, because it's using the level of these pods. So of course the service will again pointing to them, and it is kind of automatically do the load balancing. So it will distribute the traffic across the pods whenever application will you will hit on the particular service. So now you again reiterate, in Kubernetes, a service is an abstraction that defines a logical set of pod and policy for accessing them. It provides a stable endpoint like IP address and DNS names for communicating with pods. Even as pods themselves are dynamically created, destroyed, or rescheduled, services enable decoupling between the front end and back end components of an application, ensuring reliable communications. So, what are the features of services? Services provide a stable IP address and DNS name that other application can use to access the pod, even if pods are replaced or rescheduled. Load balancing. Services distribute traffic evenly across all pod that match the service selector. And I told you those level matching it does. Service discovery. Service enable automatic discovery of pod using DNS or environment variables. Abstractions. Services abstract away the details of individual pod, allowing you to focus on logical grouping of pods. And it support for multiple protocol like TCP protocol, UDP protocol, SCTP protocol. Now, there are multiple types of services. Cluster IP. So, cluster IP is the default one. Exposes a service on a cluster internal IP address. So, see, Kubernetes is installed over Linux, and inside the Linux, each pod is assigned a separate IP address. Now, that IP address is different from the host IP address. So, cluster IP service, if you create, that only allow you to access your applications within the pod network. So, exposes the service to a cluster internal IP address only accessible within the cluster. Use cases internal communication between microservices. But suppose you want to access that application on the physical nodes using some load balancers or something. In that case, expose the service on a static port on each node IP address. So accessible from outside of the cluster using node IP colon node port. So what happens if I explain you in high level term, then what happens? See, so you have your service. This is your service. And these are your pod 1, pod 2. So this 2 is pointing to this service. Now, when you are exposing your service or running your service on suppose 8080, but this 8080 is only accessible within the cluster. But suppose this service is a load balancer, or you are attaching this service is running on a physical cluster, you are attaching a load balancer. Now if in the browser you will type the load balancer, of course load balancer is not part of the cluster, so it cannot access your 8080 port. So in this case what happens, we create a service and the type of service is called node port. Node port is like it does the mapping of 8080. 8080 port will be mapped to some higher port like a port number like 32001, like something like this. So when you will do the load balancer colon 32001, it will exactly point to 8080. 8080 will point to the pod port number, and then your application will be accessible to you. So this way it works. So node port, I hope you understood, exposes the service on a static port on each node's IP address, accessible from outside of the cluster using node port. Use case development or debugging, or when you need external access but don't have a load balancer. So one is obviously some public cloud provides a load balancer type of service, but in your private organizations, if this type of service you are not using, then of course node port you can use and then you can expose it. Another type of service is load balancer. This type of service like AWS EKS cluster or Azure Kubernetes cluster or Google Autopilot cluster, GKE clusters. These clusters nowadays provide a service type itself is load balancer. So when you define your service type as a load balancer, automatically it is exposing that particular port to the external or outside world. So these are the different type of services. Of course, we'll do a lot of things practically in this, but now let us move to our project. So in today's project, we have again a Python applications, and what this Python application is doing. So in Python applications, we are having a database and we are connecting to database using this Python Flask applications. So first, to connect to the Postgres database, we have psychopg2. This is a module to make the connectivity to database Postgres. OS module we are importing, and then we are importing Flask, request, and JSONify. Again, we are creating an instance. So here app is equal to Flask name, and then database URL we are getting using os.getEnvironment database URL we are passing. So now function, function is to connect to DB. So how to connect to DB? This psychopg2.connect, and then database URL you will pass, and you are making a message print connection made, and then return the connections. Again, application root is the main root path slash, and then defining hello world, and it's returning hello world. Then again, application root if slash submit, and method is post method. Then what you are doing, request.json.get name, getting the name, getting the message, and then you are of course calling the connect method, connecting to database, and cursor is equal to connect.cursor. And after once this is done, you are just doing cursor.execute and insert into that particular table. So insert into public is the database name dot message table, and then here you are passing the name and value which you are getting as a input in the post method, and then committing it into the database, and then closing the connections. And then in the return you are doing JSONify, and status is message is stored successfully, and 201 else 201. If this is the main, this is telling that okay, this is not a module, this needs to be executed here. So app.run debug is true, and then again allowing all the hosts 0.0.0 and port 5000 we are running. So now I hope this code is quite clear. Now if you go, there is one component which I told, that is secrets we have to create, because to connect to database, obviously database username and password will be needed. So we have to create an object called db secrets. So API version v1, kind is secret, name is db credentials, type is opaque, and data, in the data you are passing the database URL. And this secret how we are getting, I'll explain you in few minutes. So database URL, how this value we got. Now, if you go Postgres deployment, first you need the database to be ready. So kind of deployment, metadata is PostgresDB, one replica, match level is PostgresDB, template is PostgresDB, spec is PostgresDB. This is the version of Postgres 1.3. Image pull policy, only pull if it's not present. Then environment, Postgres database. Value is DevOps. Postgres user is Postgres. Postgres password is password. And then it is running on port 5432. And now to connect to the Postgres database, we are creating a service. So kind is service. Name is PostgresDB service. Selector is obviously PostgresDB. And then port, it is 5432 because your this Postgres is running on 5432. So this service will connect to 5432 container port, and it is using a selector PostgresDB. So suppose here you have multiple replica, no worries, because it's using matching the level, and then this is the app level, right? So whatever the pod will be there, they will have the same level here. So it will, service will do the load balancing across all the pods. Once we deploy the service, then what is there? Next is you need to create the deployment. So deployment, Python app, name is Python app, to replica, Python app, and then Flask 0.4. This image we can maybe make 0.6 while creating. Container port is 5000. Database URL. Here you see as an environment variable, we are telling database URL, and then where we are getting value from secret key response and key reference, and here name is DB credentials and key is database URL. If you go to the DB secrets, name is DB credentials. So in the environment we are telling name is this, and database URL its value we are getting. So here if you see database URL, the key value we are getting here. Now, if you have to deploy, so first, what we have to do? We have to pull this Postgres 13 image in our system. So let us go there, clear the screen, and then pull this image. So image Postgres is pulled. If you do Docker images, you will see Postgres 13 is already here. Now you have to load this, right? So to load in your kind cluster, kind load again. So kind load, it will load to all the control plane and worker node. And once this is done, you have to create the Postgres database, right? So kubectl apply -f and then Postgres DB deployment.yml file. So let the loading complete and then we'll do the deployments. So we'll start doing deployments. So if now you see this is loading is done. So if you here see in the directory, you have Postgres db.deployment file. So kc kubectl means it's the alias apply -f and then Postgres deployment.yml. So your deployment and service file was also inside that. So it created deployment and service. If you see kc get pods, then you will see Postgres pod is already running now. If you see kc get sbc or kc get service, then you will see Postgres DB service is created and it's using 5432 port. Now, once this is done, then you have to go inside the pod. So how to do? kc execute -it. I is like as input and you are going to terminal and then copying this pod name. So pod name and then you have to do -bin sh. So I want to go inside the Postgres DB pod. So now if you click, so you see has means we came here. After that, you connect as a Postgres user. So su-postgres. So now I am inside this Postgres and to connect to the Postgres command prompt, psql is the command. So now you see we are inside Postgres. Now, if you want to see how many tables are there, so describe tables. So we are now inside this. Now suppose first we have to, because no tables were created, so we got the empty message. Now create table messages. So if you do create table message, ID name and message, so create table is returned means it's created. Now let us try. So you see message table got created. Now you know database URL. So update database URL in application code to build the image. So this is the database URL. How to pass it? Postgres, Postgres, colon, and its password is this, and the service is Postgres DB service, colon, which port it is running? 5432/Postgres. So this is the database URL. Now, if you will do this database URL and you have to, before building the image, you have to pass this database URL and then you are doing the Docker build and we have made it as in the deployments. If you go, so Postgres deployment is done. If you go to the app deployment, here image tag we have given 0.6 and here we are passing the key as a database URL. So now what we have to do, we have to first build the image. So with this Docker file, you first you exit here, exit, and then here you see a Docker file is there. So cat Docker file, and if you say what we are doing here, Python, and then web app, and then installing this psychopg binary, numpy and panda, exposing 5000 applications, and here you are running the Python app.py, and then this will run. So just now do Docker build, but what you have to do, Flask app we have given the image tag as 0.6. So let us do the same. 0.6 and just type it here. So it has started building the image now. Image is getting built. So yeah, now you see downloading psycopy binary and those things. And then it is moving ahead, installing NumPy, Panda, those inside our Docker image. So it's taking some time to get it done, but yeah, just wait a minute, it will be done. Once this is done, of course, we have to load again. So for loading again, this is the image tag. So we have to load it now. Once this image building is taking time, so this Flask app we have to load inside our kind cluster, and after that, this echo we are doing Postgres password, Postgres DB service, and there we are decoding it. This complete URL, how we are decoding, I'll show you. It's taking time. Okay. So now our image build is done. If you do Docker images, you will see 0.6 is here 6 seconds ago. Now, what you have to do? You have to load this image into your kind cluster. So let us do the same. So to load it, just copy and then go here and load. So now it has started loading to our kind cluster. And after that, this is exactly doing? This is connecting to Postgres and then using this service, and whatever after the connecting, it is just getting the credential details. So create database URL as secrets. How we'll do? Let us see. Because this complete database URL we have specified, and in the URL what you have to give? Your database name, then database password, and then the service name because you have to connect to the database service, and then the port details. So now this whole thing we want to create as a secret, and this secret as a URL we are passing to our Python code. So now you can see our loading is done. Now what is next? So you have to get this, connect to it, and then get the encoded form. So if you see, I got this as a URL. So what we are doing exactly? We are just finding a way to connect to database, and then just we are making it base64 encoding. So this value we got, just take a note of this value and go to your secrets. And if you see here exactly, so same value which I got, I pasted here. So if you match CG9ZDXY, and in the last ZXM equal to ZXM equal to. So this proves that whole your database URL is getting converted into a secret. So now you understood this. So what is the next step then? The next step for us is apply the secret. So just do kc apply -f secrets db secret.yml. So your secret is created. How to get? Kc get secrets, and you will see db credential secret is already created. Now once this is done, you have to apply, create the deployment. So kc apply -f, and in the deployments already we changed the image to 0.6, right? And this file has been saved. So kc app hyphen deployment app hyphen deploy main.yml. So deployment is done. Now once your deployment is done, after that you have to create the service. So app service kc apply -f, and then app service.yml. So your service also got created. So if you get kc get po, then you will see Python app is deployed. And if you do kc get svc, your service is also done. So Python app service and Postgres DB service both are created. Now create the port forwarding, because you have to forward the port. Previously we used to do port forwarding for our port exactly, but now it's a load balancing, right? Because service is created. So you do the port forwarding for service. So port forwarding for service. So now you see this port forwarding is getting done. And after that, if you go to web browser, you should be able to visualize it. So if you see here, then localhost colon 5000. So see, your web browser is accessible. So port forwarding is working as expected. You again refresh the page and you will see handling connections again. So handling connections, refresh, you do multiple refresh of it, and you will see handling connections. So now it's able to connect. Now what's next? Suppose I want to access these applications using curl in the local system. And what I want to do, I want to submit a message inside the database with the applications interacting like DevOps, and message is take a stack, hello take a stack. So what we are doing, curl hyphen x post http, this is the localhost colon 5000 slash submit we are calling, and then as a header content type we are passing as application JSON, and then in the data name is DevOps and message is hello text DevOps text stack. So if you copy this and just close it now, because with the command prompt we have to submit the request. So if you do this, okay, so what message we got? It's telling could not connect to the server. Why it cannot? Because your port forwarding is not working, right? So if you want to do, we can do the port forwarding in the backend. To do it in the backend, maybe no hub, and then here put the and percent symbol, and now port forwarding is working. Let us try again, Carl. So you see message is stored successfully. How I can verify that? So to verify that, you have to connect to database. So do one thing, kc execute, go inside the database, and then su hyphen postgres, and then psql, and then slash dt, describe tables, and then select a star from messages was the table name and semicolon. So here you see hello DevOps, hello tech stack. If you want to try it again, let us give one more try. So this, and instead of hello tech stack, we are telling k8s test tech stack, and name is demo python. So message is stored successfully. Now go inside the pod and then again run su hyphen postgres, and then psql, and then select star from messages. So you see this is already published. So I hope you understood this completely, how to create a service, how to deploy a Python applications, how to connect to the Postgres database, how to create the two-tier applications, how to make the communications among them. I hope this concept is quite clear to you guys. In this project, first your learning will be what is job in Kubernetes and how to take DB backups using Kubernetes. So first let us understand what is job. In Kubernetes, a job is a controller object that manages the execution of one or more pods to perform a specific tasks or workload. So job is mainly designed to perform a specific task. Unlike other controllers like deployments, replica sets, which are designed to run continuously, jobs are intended to run tasks to completion. So job is like some task you want to do, just it will complete and it will stop. This means that pods are created by job, will run until they successfully complete their work and then they terminate it. So what are the main characteristics of job? Task completion. A job ensures that a specified number of pods successfully completes their task. If a pod fails, the job can automatically create a new pod and retry the task. Finite workload. So jobs are ideal for batch processing, one-time tasks, finite workloads, running a database migration, processing a batch of data, or generating a report. Parallelism. Job can run multiple pods in parallel depending on the configurations. completion count. You can specify how many pods need to complete successfully for the job to be considered complete. And backup limit. If a pod fails, job will retry the task in the specified number of times before making the job has failed. Some use cases are like running a database backup or migration, processing a batch data, running one-time script, or performing a cleanup task. In our case, we are going to run a database backup using the job. Let us go to the concepts. So first let us see. Let us try to take backup of our Postgres database, which I have recently done in my project as we have migrated to GCP Cloud SQL. So we'll create a simple job object to take backup of our database, and job name is job.yml. You can check the log of pod created for taking backup. Also check the node on which pod is started. Execute into above node and check the host path if backup exists or not. So now let us see. So batch API version is batch/v1, and then kind is job. Metadata is Postgres backup job. In the spec, in the template sections, Postgres backup. Image is Postgres 13. Image pull policy only if not present. And in the command, you are telling in the bash shell, executing the command echo starting Postgres backup, and then Postgres password is equal to password, and pgdump is a utility. So pgdump -h, and then your service name, -u is username, -d is your database name, and -p is port, and then you are specifying verbosity. Let us check this later. And apart from that, -f, and then you are telling the dump file name. And the path is where backups Postgres backup.dump. And then once this is done, you will message that backup completed. And where you are mounting in the where backup path, and name is host backup. And then restart policy only on failure, and volume will be host backup, and host path is exactly where backup path. Type is it's a directory which exists on the machine, and backup of limit is 4. So this is a normal job which you have to create it. So now let us go here and do this, because your database is already running and you are currently inside the Postgres. Exit here and then go here, cd dot dot cd day 4, and here if you see we have jobs.yml. So kc is qctl apply -f job.yml. So your job is created, and then you will see kc get pods, and in the pods you see one Postgres backup job, and it's already completed. So now if you see logs, so kc is qctl again, kc logs, and then your pod name. And if you do, so here you see a starting Postgres backup, and then it is started, and then it is reading, and then it is telling backup completed, and dumping into public, means our message table was having the data, so it has dumped the content of this. So backup done. How to verify now? First see kc get -no pods -oy, which node this completed pod was running. So this was on DEVOPS-TECHSTACK cluster worker. So this was on this node, right? DEVOPS-TECHSTACK cluster worker, and then PostgreSDB is running on worker 2, worker 2. So I will see kc get nodes, and it was on worker, this node, right? So, so since our nodes are right now running as a Docker container, because it's a kind cluster, so you can do Docker PS, and in Docker PS you will see the container ID. So cluster worker, this is the ID of that particular node. So what you have to do, you have to go here and Docker execute -it. You have to go inside that particular node, right? So Docker execute -it, and then this ID is here. We got the IDs this, because this is, you see, cluster worker, and this node only our pod has executed. So this, and then we inside this node, And once we are inside this node, you have to go to where backup. So cd slash var slash ls hyphen ltr, and you see backups, cd backups, and if you do ls-ltr, you see postgres backup.dump was already taken. So in case you have to restore your database, you can use this dump to restore it again. So I hope on a high level you understood how to take the database backup using Kubernetes and how to deploy the three-tier applications, which we already did in our previous lecture. So the project name is HPA Auto Scale of Applications whenever there is increase in the CPU load. I'll show you the demo project when CPU load is increasing in the system, how exactly your applications will auto scale. Now, you might have question in your mind. Is the criteria only CPU load? No, you can define multiple criteria like memory increase or even some errors in the applications, or maybe traffic is increasing. So many custom kind of metrics can be defined to scale your applications. But in this project, you are going to learn how to scale your applications whenever CPU load is increasing on your pod. So scaling application with HPA. HPA means horizontal pod autoscaler. Horizontal pod autoscaler means your pod will scale horizontally. Means suppose you have one pod, if HPA will help it to grow from 1 to 2, 2 to 3, 3 to 4, depend on the limit number of pods which I am defining. So it will help you to automatically horizontally scale your pod. This project you work through setting up HPA, configuring resource limits, and testing auto scaling in action. So what you will learn by the end of this, you will understand how Kubernetes dynamically adjusts workloads to handle varying traffic efficiently, ensuring optimal performance and cost savings. You might have a question that why I have to scale my applications. In the beginning only you will decide large scale applications. But suppose you are running your workloads in public clouds. Now, if you go to public cloud and you assign 10 replica of your pod, every day you have to pay that much cost. But suppose your traffic is only for one pod, you are wasting 9 pod resources. So in those situations, we implement HPA, which help us to scale whenever needed, and whenever the traffic is down, it will automatically scale down. So your cost will be saved and your application will work efficiently as per the requirements. Going ahead, what topics you will understand? What is HPA? How to configure HPA and deploy this project end to end. So first understand HPA in detail. HPA is horizontal pod auto scaling. HPA automatically scale the number of pod in deployment replica sets or stateful sets based on observed CPU memory uses or even custom metrics, as I have explained. What are the features of this? First is automatic scaling. So adjust the number of pod dynamically based on your resource uses. CPU and memory based scaling, like default behavior scale pod based on CPU or memory utilization. Even custom metrics you can send, and it can scale applications based on your specific metrics like rate of request or traffic. Optimize resource utilization, I explained you. Prevent over provisioning and improve your cost efficiency. And periodic monitoring. Continuously check resource consumption and adjust your pod accordingly. So, as you understood this, now let us go and implement everything using code. So, here I will take you in day 5. In day 5, what all things you are learning, let us see. First thing, HPA. One is matrix and one is PHP applications, which I am going to deploy. First, let us understand what is this matrix.yml file. So, Somehow your application or HPA need to know CPU utilization of your system. Now, to get the CPU utilization of your system, you need the metrics to be collected in your system, like all the metrics, like how much CPU is getting utilized. Those things needs to be collected. So metrics is one of the way. Metrics will collect all the pod related metrics, and this will help you to get the CPU load, and then that data can be used to scale your applications. So you might have a question in your mind. Do you need to write each and every line of this matrix.yml? No need. This matrix is an open source tool. You can directly go in GitHub and you can find the matrix.yml file and you can directly apply that. So what all things are there in matrix? Service account needs to be created. Then cluster role is defined, and here you are giving permissions to matrix resource, pod and node, and you are getting permissions like get, list and watch. Then cluster role again, and this has some specific set of permissions. Then role binding we are doing, then cluster role binding. So these all details you can, we don't have to go in deeper of it, but yeah, one thing is important. So in our system right now, it is not deployed in the secured way. So when you deploy it in your kind cluster or in your test system, you have to enable this parameter kubelet insecure TLS. By default, it needs the secure TLS, but since in our case we don't have the SSL certificates, so you can make it kubelet insecure TLS. This you have to keep in mind. Now, once this is done, then rest all things, I will not go through each and every line. So this is an open source matrix. Just you can go and get from GitHub, or we'll share our code. Directly go and apply it on your server. So here I am inside day 5. Go here and just do matrix.yml. So qctl apply -f matrix.yml. So just do it. So you can see service account created, cluster role got created, role binding, service account, then deployment, and then API registration. So matrix is done. Now, once matrix is again going to help you to collect the metrics of your pods, like how much CPU load is there, how much memory is consumed, and other metrics related to it. Once this is done, let us deploy our PHP applications. What this application is doing? So API is application v1, kind is deployment, name is PHP Apache, and in the spec we are defining the pod selector, and in the selector it's PHP Apache, template PHP Apache again. In the specification, name is PHP Apache, image is stored here, and this is the public place where I picked it. So this is the image name, and then it's running on port 80. Resource limit we are defining 500 CPU and 200 memory, and then we are creating a services again, it's exposing the port 80. So I hope you understood this deployment and service. So just do kc apply -f and then php.yml. You might have a question, why kc? So qctl, I have made the alias of qctl to kc. So if you do, so you can see deployment is also created and service is created. If you want to see kc get deploy or deployment, so if you see PHP is created, but still you see up to date is 1, available is 0. So it will take some time to bring the pod up. So let us see get what is the status of pod. So pod is showing container creating. You can see the log as well. So how to see the log of pod? Let us see. So kc logs, and then you can just do this pod details and you can see. So it's telling waiting to start the container. So let us wait. So now you see pod is in the running state, and if you see the logs, you see it's already available. Clear the screen, and then now you have the pod working. So if you see kc get deployment, you will see it will be everything is ready. So one is available now, up to date is 1, and ready is 1 by 1. Now, once your pod is deployed, now I want to deploy HPA. So the kind of object it is horizontal pod auto scaler, and its API version is auto scaling slash v2. Metadata name as you want you can give. Here I have given PHP Apache -HPA, and in the specifications scaling target reference we have defined. So what was the API version of deployment? app/v1. If you go here, target API reference is app/v1. So target API reference is app/v1. Kind is deployment. It was a kind deployment, and name is PHP. So name is PHP Apache. After that, minimum replica we are telling is 2. Let us make it to 1. And then maximum replica I am telling make it till 10. And what is the matrix you are collecting? So you are telling resource if type is resource and resource name is CPU. And target you are telling if its type of utilization, average utilization is 40, then you have to make the maximum replica till 10. So now save this and go and apply HPA. So KC apply -f and then HPA.yml. And if you see it is applied or not, so KC get HPA, and you will see HPA PHP Apache HPA is done. It's referencing the deployment PHP Apache. Minimum pod is 1, maximum pod is 0, sorry, maximum pod is 10, replica is right now this is 0 and it's 6 seconds. And here you see target, it is telling CPU is the reference. And now here if you see, initially it was trying to get the CPU value, initial value, but right now it is telling that pod CPU utilization is 0. Now it's telling that pod CPU utilization is 0. So how to increase the load on our system so that we can see that pod is automatically scaling? So first let us do one thing. Let us create a parallel screen here, and then we can try it. So let us go bits this side. Let us go here. Just to do this. Let us maybe minimize it. Yeah. So now we have two screens. You can see. And here what I will do. Here I will run some load generator. How load generator will be done? So see. Load generator command is kubectl run -i means as a input terminal load generator, and then image is busybox and restart is never. We are going inside the pod of busybox, and then we are running simple while sleep 0.01 colon means it is running in a loop always, and then do what we are doing wget -q -o, and just we are doing http php apache means we are hitting our applications php apache, and php apache is the service name also, and then done, closing it. So just copy this load generator, go in this first screen and just type it. Once you type, you will see okay, okay, okay. Every time okay means it is hitting and it's getting the result. So you see now okay, okay. Let us open the parallel screen. So let us see parallel screen, and here you see KC get HPA. So if you see right now load is okay, just put watch over it. So you see CPU load is still 0 only. It will take few seconds to get the matrix and then scale it. So now you see your CPU load has increased to 112%. Gradually it will increase more, and here you see load generator is generating the load for us, and CPU is already increasing here. Here you see now 248%. Now, in the meanwhile, what you do, you take one more screen. And here if you see KC get PO means your pods, you see how many containers are creating. 1, 2, 3, 4, 5, 6, 7, and it keeps on creating. Means your pod is automatically scaling now. So this proves it. Now you see load is 155%. And if you go here and see the pod, again you see now these many pods are running. So how many? 1, 2, 3, 4, 5, 6, 7. 7 pod, and it will keep on increasing, and it will go till what value? 10 is the maximum limit. So it will go till 10. Now, if you see load is 96, and this way it will keep changing and keep increasing. Now, you might have a question. If I stop this load generator, what will happen to pods? So if you see current pod here, still you have many pods running, right? But within few minutes, it will scale down. So I am putting watch over it, and you keep an eye on it. What you will see, in few minutes, all the pods are destroyed and it will go to the minimum value, because if you do KC get HPA, you will see the load is reducing slowly. So now it's 41%. Slowly it will go down. So if you keep checking, as the load will go down, so now load is 7%. And if you see pod now, you will see pod is still running till the time. Slowly you will see pod will start deleting. So now see, CPU load is 0, right? Now load is 0. It will take few seconds, and after that, so now load is 0. Let us see. So as I explained you, the pods will automatically terminate, and here you can see pods are terminating. So you see it got terminated, and now if you go and see number of pods running here, it will be one pod. So other all pods have been automatically terminated. It has taken few minutes to terminate, but by the end it has terminated all the pods. So this is the real beauty of using HPA. So now, as you understood, what all things we have done. First, we have implemented matrix, because matrix is helping us to get the system or pod related matrix. Then I created an application, that's a PHP application, and this is the place where image was placed. And then we created a simple PHP service. That's it. And then we implemented HPA. And in HPA, very important point was scale target reference was API version was app v1, then kind is deployment and the name of app. And what was the metrics criteria? Type was resource, and then resource name is CPU, and its target type was utilization. And we defined average utilization as 40. So I hope you understood what is horizontal pod auto scaling, how the metrics can be deployed on your servers, and this is helping you to collect the metrics related to your system. And here if you see in this deployment, it is getting the readiness path of the system, and apart from that, it is collecting other details related to it. If you want to go into deeper of understanding the metrics about the metrics collector, you can go and read about it. Otherwise, we'll make some videos related to metrics as well. And in today's project, we are going to learn how to do scheduling of pod restart to prevent memory leaks or performance issues. So, what happens in organizations? There will be some requirements where you need to do some regular restart of the pod, maybe on the weekly basis, whenever the traffic is almost to zero. So there are some problems like memory leak happens. So some application might suffer from memory leaks or resource leaks, where application is gradually consuming more memory or other resources over time without releasing them. And this can eventually lead to performance degradation, crashes, or excessive resource consumption. So some problems are like some applications may accumulate temporary file, session, or data in memory over time, which can eventually lead to slowness or performance bottlenecks. So what you will learn in this project, how to create or how to deploy the projects which can help you to do automatic scheduling of restart of your pods. So, in this, whatever you will understand is how to do the scheduling of pod restart, how to deal with rule-based access control, that is permission issues, and how to create a namespace in your Kubernetes cluster. Now, first thing comes in our mind, what is namespace? So, namespace in Kubernetes is a way to organize and isolate resources within a cluster. It is useful when multiple team projects or environments like dev, test, or production share the same cluster but need a logical separation. So why use namespace? Resource isolation. So it prevents conflict between different application or teams. Access control. So allow role-based access control to restrict user permission per namespace. Resource quota. Limit CPU, memory, and other resources per namespace to prevent its overuse. And it's a better way to organize as well. So how to create it? kubectl create namespace and my namespace name. So how we will do? kubectl create namespace and then suppose test name. And if you see kc get or kubectl get namespace or namespace short form is ns, then you see here already test name is created 6 seconds away. And if you have to delete it, kc delete ns and then test name, and it will delete that particular namespace. So this way namespace can be created. Now role and role binding. So a role grant fine-grained permissions, example read write permission to resource like pod, services, secrets within a single namespace. Role binding, assign a role to a user, group, or service account, granting them the defined permissions. So role is like uh, type of permissions like read, write, and what kind of resources it will be applied like pod, service, secrets, other things in a namespace. Role binding is assigning that particular role to a user or a group or a service account. So granting them a particular kind of permissions. Next concept, how to do scheduling of job. Before that, let us understand what is cron job. In Linux environment, cron job is a way to do a scheduling of jobs. Like you want to run your backup at a specific time, you can go and create a cron job for doing that. So in Kubernetes also, a cron job is a kind of Kubernetes object which is useful for periodic jobs like backup, log rotation, data processing, pod restart, etc. So what is the cron format? So cron job will have 5 star, and this 5 star, the first star will be minute, like what minute you want to deal with the time. Next is hour. Next is day of the month between 1 to 31. Next is month, which month? First month, second month, third month. And then day of the week, which 0 to 6. 0 is Sunday, 1 is Monday, 2 is Tuesday. Month is like first month is January, Feb, March, this way. Day of month is 1, 2, 3. And then hour is 0 to 23. And then minutes 0 to 59. First value is minute, then hour, then day of month, and then day of week. So this is the cron job format. Now, as you understood these things theoretically, let us go and do everything practically. So first thing, we have to create a deployment. So what deployment I want to do? I just want to create a deployment and its name is Jenkins and I want to create it in the Jenkins namespace. First, let us see we have Jenkins namespace here or not. So kc get namespace and I don't see any Jenkins namespace. So first kc create namespace and the namespace name is Jenkins. So our you can see namespace Jenkins is created. And if you want to see it got created or not, kc get namespace and then you will see Jenkins is already created 10 seconds ago. Now clear the screen, move next. So once namespace is created, you want to define the specification like one replica, app level is Jenkins, and then we are downloading the image from the internet. So Jenkins long-term support. And if not present, image pull policy. If it's not locally present, then it will pull. Otherwise, it will use the local image and then it will run on port 8080. So just go here today 6 and just do kc apply -f and your Jenkins deployment. So Jenkins deployment.yml. And if you see kc get deploy hyphen n, now it's in different namespace. So hyphen n Jenkins, and then you see it's still not ready. So kc get po means pod hyphen n, and your namespace name is Jenkins. So you see container creating a state. It's taking some time, but it will be ready. Now, once it is done, then you need to create a service. Service, we are running it on port 8080. So we can do type is maybe node port or load balancer or any type you can define. So kc create hyphen f Jenkins hyphen service.yml, and if you see kc get svc denotes service hyphen n Jenkins. This is the short form. So you see your service type of load balancer is external IP. It is because local machine, so it's not assigned, but service is created. Now clear the screen and see kc get po hyphen n Jenkins, and if you see it's in container creating a state here. Just see the logs. kc logs this hyphen n Jenkins and see what is the problem. So it's telling a container in pod is waiting or container creating. Just describe this pod. So kc describe pod, and then the pod name is Jenkins, and then namespace is Jenkins as well. So if you see here, image is pulled, then creating container, started containers. So first you see 98 seconds ago successfully pulling the image, and then pulled the image, and then created the containers and started containers. Again, see now what is the status. So if you see now, it's in the ready state. So Jenkins is running in our system now. Now, once Jenkins is running, then what next we need to do? Since we want to create a cron job, and what this cron job is doing, its API version is batch/v1, kind is cron job, metadata, name we are telling is weekly pod restart, in which namespace? Jenkins namespace. You can replace with your target namespace. What schedule you want to run? Here 58 means 8:58 means in the morning, 8:58 you want to restart it every day. Now, this schedule you understood, right? So in this schedule, let us see when you want to restart. First save this. Then in the job template specifications, you are telling container kubectl, and you are using the kubectl image there for restarting it. And then what you are doing? You are running the command kubectl delete pod hyphen level app is Jenkins and namespace is Jenkins. So you are just downloading the kubectl inside this cron job, and then you are deleting the particular Jenkins pod. So once you delete the pod will automatically recreate. And restart policies, only if there is a failure, it will restart, otherwise it will not restart. And why app is equal to Jenkins? Because if you go in the deployments, here you see level is app is Jenkins. That's why here we are giving app is Jenkins. So now if you want to create this cron job, let us go here and just do kc apply hyphen f cronjob.yml. So your cron job is created now. How to verify it's created? So if you go here and if you do kc get cj means cron job, no, because it's using default namespace, so specify your namespace as Jenkins, and then you see its schedule is 8:58. But I have to check my system time. What is the current time in my system? And we can schedule it and check it's working as expected or not. So let us open more sessions of this machine. Okay. And here what I can do, I can first check my nodes. So kc get nodes, and then it's a kind of Docker container. So Docker ps first check, and you see you have multiple nodes. How to first go inside any of the pod? Uh, of so kc is this is Docker execute hyphen it, and then slash bin. So this is like I'm going inside one of the pod, and this pod is exactly a node for you because you are using kind cluster. So I'm going inside one of the pod, and here I'm checking the current date. So in date, all our node is having timing in UTC and current timing is 10:35. So let us do one thing. Let us modify the cron job. Go here and check your time. So it's 10:35 now. You can schedule it at 10:37. So go here and change it 8 to 10, and then here you can schedule it to 37. So now it's 10:37, and then apply KC apply hyphen F cron job hyphen YML. And if you do cron job check now, so you can see it's scheduled for 10:37. And if you go here and check the date again, you will see it's 10:36:22 already. So I hope timing you understood. So let us exit from here and just do KC get PO hyphen N Jenkins and keep it running. And then here you see uh, it's 10:37, and within a few seconds there should be something which will be happening here. Let us see what will happen, and then I will explain you the problem, and then again I will explain you the solution of this as well. So if you see now, job active is 0 right now, but now let us put the what, and you see last schedule is 2 seconds ago, one is active. And here if you see, it's in showing pod restart is in the pending state, and here it is again creating the containers. Somehow it's not running, means it's not able to. This job, cron job, this is a cron job, this is pending creating, but our Jenkins is continuously running. So somehow it is not able to restart our pod. Why? Let us see the log of these pods first. So just go here, and if you see KC logs, this hyphen N Jenkins, and you see one error. Error from server forbidden. Pod is forbidden. User system service account Jenkins default cannot list pod in API group in the namespace Jenkins. So here we got some permission issue for our service account which don't have the permissions in namespace Jenkins to list the resources like pod, and then maybe delete those pods as well. So this is the reason we are not able to do our job. So here if you see, it has crashback loop off now, and it has given up. Maybe it given up because why? Because it doesn't have the permissions. So if you see again here, so the same error you are getting continuously. So now let us do one thing. Just clean up everything, or clean up this cron job. That's it. So what we can do now, just delete the cron job as of now. So, and then we'll do again KC delete cron job, and your cron job name is weekly pod restart, and then your namespace is Jenkins. So I have deleted. If you do now KC cron job, so you have nothing. It's fine. Now first go and see the code. So cron job, we got some error that these pods, cron job pod, cron job is creating a job, and job is in form of pod. So one pod is not having permission to list the resources and even delete the resources. So for that purpose, we have role. And what is this role? RBAC authorization k8s IOV1, and kind is role. Metadata namespace Jenkins. Name is pod reader I am giving. And then rule we are telling all the API group, whatever the API group for pod, resource is pod, and verb is like permission. So verb is telling getting, listing, and deleting permissions, and then API group applications for resource deployment type, getting, listing, and deleting. So now this role will help to get, list, and delete both for deployment and pod, and which namespace Jenkins, and then the uh, name of this role is pod reader. So go and first, before deploying the cron job, KC apply hyphen F pod reader role dot YML. So our pod reader role is done, but this role is now not used by anyone. So you have to do the binding, like this role needs to be binded with someone. So if you go to pod role binding, then kind is role binding, metadata name is pod reader binding, namespace is Jenkins, subject you are telling service account. In the default namespace we have a service account, name is default, and in namespace Jenkins, what you are telling. Role reference is kind is role, name is pod reader, and API group is RBAC authorization k8s0. So this will bind and give your default service account the permissions in the namespace Jenkins. So if you go here and now do KC apply -f pod role binding binding.yml. So now your role binding is done. Now create the cron job again. But this cron job is 1037. So go here inside the pod and then inside the node and check the time and accordingly identify. So it's 1041. We will make to 1043. So go here and make it 1043. Save this and then just go kc create kc create -f cronjob.yml and clear the screen. And now if you see kc get cj-n Jenkins, then it is scheduled for 1043. Right now active is 0. And here if you see just the timing now, it's 10:41:55. So wait for 1 minute. Meanwhile, let us see what. Here we can do kc get po-n Jenkins, and you see one pod is running. Put the watch over it, and here you can here you can see your cron job again. So your cron job is still not active because it needs 1 minute, right? So 1 minute of time it needs to get active. So within a minute it will be active. Let us wait for this. Meanwhile, let us change the color so that you can define. So this one here we are running, putting the watch on the cron job. So right now active is 0, and here pod is still in the running state and we don't see anything. And in this screen it's not in the active state yet. So it will take, since we have put 1043 and UTC time is still not 1043, that's why we are waiting. Within a minute it should be active is 0. So now you see here Jenkins has started creating, and here you see one job is active. And here if you see Jenkins is running 1 second ago. And if you see now, kc get pods -n Jenkins, and what you will see. So your job is also completed successfully, and the pod related to cron job, and your Jenkins is restarted in 18 seconds. And if you see the log of this, what you will see, let us see, kc logs this -n Jenkins. And what you see, so it is giving some message, and these are the message. But anyhow, finally it was able to restart, and we got no any error. Our pod got restarted successfully. And if you do kc get cj cron job now -n Jenkins, and you will see active will be 0 again, because last schedule was 57 seconds ago. It has already done the job, and now timing is 10:43. You can define every Sunday, so you can modify this. Instead of this star, you can put 0. So every Sunday 10:43 it can restart. This way you can change the schedule of your cron job, which will help you to do automatic job which you want to perform. So I hope you understood how cron job works, how exactly we can do weekly restart of pods, or how to deal with the cron job, what is role, what is role binding, and how everything works collectively. In this project, we are going to deploy Node.js applications in Kubernetes using the concept of config map, and how dynamically that can change the config map, so your application will be changing accordingly. Many real world applications need to read configuration values like database credentials, API key, etc. at runtime. With Kubernetes config maps, you can manage app configuration dynamically and securely. Now, what are the key takeaways which you are going to take from this project? How to deploy Node.js applications in Kubernetes using the concepts of config map for configuration management in Kubernetes, and creating and managing Kubernetes resources. Let us understand first config map. A config map in Kubernetes is an object that allows you to store non-sensitive configuration data that can easily accessed by your container or pod. It separates your application's configuration from its code, make it easier to manage update configurations across different environments without changing the app itself. In a layman term, if I explain, a config map is a configuration file which you store on your servers, and whenever you modify the config map object, it can dynamically change the application values if application is referencing it. Just take an example. Your database name is XYZ and you are calling it inside the code. Your database name got changed and now it is ABC. So if you update your config map, the pod can automatically know the value of new database, that is ABC. How to create a config map? One command is imperative command, that is kubectl create config map app config from literal message and some message I am passing. Another option is you create a config map file, kind will be config map, and then define the config map details. So this is imperative and that is declarative way. You declare everything as a code and then you create it. Second, since it's a Node.js application, so there will be a package.json file that defines your Node.js application metadata, dependency, and script. And server.js file is the entry point of your application. Sorry, it's written wrong here. It's not server.json, it's server.js file. Now, if you go to our code base and see how exactly it's working. So, first is see your code. In the code, we are defining express is equal to require express. Express is a kind of, in Python, we used to import the modules like request module and other modules. In Node.js also, you are just importing it. And then constant app is equal to express this curly, this small bracket. This means you are creating an instance of it, means whatever the value this express is having, you are getting a child and using app, you can get that value. There is a message, a variable, a constant, and in the message you are getting process dot env dot message, or there is a message variable somewhere. This message value you are getting. If this message somehow is not having a value or it's empty, then it's a or this message will be printed. And then in app.get, since app you already got the express related details, so now app.get, in the root path of your web browser, request or response. REQ is request. So if any request comes on this or response comes on this, so this response, what response will be sent? Response will be sent is heading 1, and there will be a message, and this message is the actual value of message which you are getting from the environment variable. This message, and then where you are running this application on port 3000. So environment.port, if it is not defined, it will run on 3000, and app.listen port, and it will print a message server running on port, and this particular port your server is running. You don't need to go in deeper of this, but on a high level, I hope you understood this. Then package.json file, it defines like the name is node k8 applications, version is this, descriptions, then scripts and dependencies, few things we defined here. Now we have a deployment. In the deployment, of course, the kind is deployment. Metadata is node app. In the specifications, we are telling to replica. Match levels is node app. In the template is node app. And then in the spec sections, image I am telling node colon 1. This will be the image tag. And then it will run on port 3000. And we are getting one environment value, environment from config map reference, and name of your config map is app config. So we are getting this environment value from config map, and here config map is used as a reference. So inject config map values as environment variables. So as an environment variable, it is getting it. So inside the pod, you can get as an environment variable this value. And then we are creating a service. Service is node app service name, and then selector is node app protocol. It's running. Inside the Kubernetes cluster, it will be listening on port 80. The target port of your container where it is running is 3000, and node port. Node port is like your Kubernetes physical node or load balancer, which it will be exposing is port 3080, 30,080, and type of service is node port. I have already explained about the type of service in previous projects. So type of service is node port here. Now here very important point, right? Environment from, and as your environment value, you are getting the value from app config map. Now go to your config map, and in the config map, kind is config map, app version is v1, metadata, of course metadata name is app config, which you are referencing in deployment, app config. And then in the data section, you have a variable, it's in the JSON format, message, and message is having a value hello from DEVOPS-TECHSTACK Kubernetes config map. So this is the message. Actually, this message value will be set as the environment value, right? So environment will get this message and its value. So there will be an environment message and its value will be this. Now, if you go inside the code, you see here you are referencing the message. So this config map will be imported as the environment variable inside your pod, and then your code is exactly getting the environment variable from pod, and then you are printing the message. If this message somehow not work, then this message will be printed. So I hope you understood all these concepts. Now we have a Docker file. Docker file is node version. From this version will be downloaded officially. Then work directory is app. You are copying your package.json, then installing npm, copying the code inside the container, and then exposing 3000, and then running your code node and server.js. So now let us go to our server and implement it. So first let us close this screen, go here, maximize it, close this, clear the screen. This project is day 7. So day 7, and I assume if I have deployed something prior, so delete everything, kc delete -f, and you can directly tell the day 7. So everything which is created as part of day 7 will be deleted. So it has already deleted whatever the things were there. So it is telling error deleting not found, but that is okay. This means everything we have already cleaned in the past. Okay. So now go inside the day 7 and start doing one by one. First thing is, of course, you need to create the image out of it. First, let us check you have images or not. So Docker images, if you see, I have already node 1 as the Docker image. But understand, this Docker image is still not loaded inside the kind node because it's locally available. So first thing, instead of creating the new Docker image, we can use the same because I have created it, or you can run docker build -t and then give the tag, like this command will be used. I'll show you again. So you can do docker build -t tag, and then your application name node colon 2 and then dot. So what it will do? It will create a new image with dot colon 2 tag. Now if you do docker images, you will see node with 2 tag is there. But this image is still not inside the kind cluster, and it is locally available in the system. So first we have to load it. In the previous lectures, I have explained you how to load, but let us see the command again, how we can load it. So to load it, we have a option kind load. So kind load, go here, clear the screen, kind load, and your image name. So here image name is kind load docker image, and image name is node colon 2. So what it is doing, it is going to load the local PC image node 2 to all the nodes of our kind cluster. So while it is loading, let us modify our deployments, because in the deployment you are referencing node 1. So here go and modify node 2, save this file, and just wait few seconds, let it load. Once loading is done, we will be good to start deploying our applications. Meanwhile, let me open one more screen to so I am taking one another screen here. Uh, Let it open. Okay. So another screen is there. Meanwhile, go to the folder. Okay. So I'm already inside day 7 and here loading is still happening. While loading is happening, no problem. We can see other components. So in the config map, there is no problem. We can apply. So kc apply hyphen f and then config map dot yml. So our config map is created. Your image is already built and image is still getting loaded. So now loading is done. Now we can go and do other step. So ls-ltr and now what you have to do? Config map already I created. So now you have to create the deployment. So kc apply hyphen f deployment.yml. So you see deployment and service is created. Now you see kc get svc and you see one node app service is created and it's mapping 30,080 port. And if you see kc get pods, you will see your node app, 2 copy of your node application is running here. 2 copy of your node application is here. So now your service is ready, deployment is ready, pods are running. So now, and your config map is ready. One thing we will do, one interesting thing, go inside one of the pod. So kc execute means execute this hyphen hyphen, and if you want to take the bash shell, then bin hyphen bash and clear the screen here and do env. What you will see in the env, many environment values are already there. In this one message of environment value coming message equal to hello from DevOps Tech Stack Kubernetes config map. So I was talking about this environment value. So inside the pod, this environment value is already fetched from the config map because you have used config map as a reference and this is referencing as a message here. Now you understood this concept. Now what next needs to be done? Next is, since you have exposed your application on node port service 30,080. So by default, your application localhost 30,080. In our case, everything is running on local machine. So obviously you can access it on this. In companies, you can access use the load balancer IP address. So if you go to browser and localhost 30,080, previously it was not working. Now if I do, so here you see hello from DEVOPS-TECHSTACK Kubernetes config map. So what I see that this config map is getting read directly by our pods. Now you suppose, let us try to do one thing I'm just curious to understand how this config map reloading works. So vim config map.yml. Suppose here instead of this message, I just want to change message is just okay. Sorry, just give me a second. I typed only. Just open this config map, delete the complete message here, and just put paste config value at real time and save this. Clear the screen and just do kc apply -f config map.yml. Go inside the pod because your pod is already running and try env again and let us see what happens. So here you see this is still referencing the old message. So at the runtime, it's not loaded here, right? Somehow It's not loaded. Whereas if you go and see kc get cm, cm means config map, kc get cm, your config map, and then app config hyphen o in form of YAML, what you see, your app config test config value at real time. So config map is updated, but somehow your pods are still not having the value. So it is still referencing hello from DevOps Tech Stack. So what we can do in organizations, generally what can be done, KC get PO. You know you have multiple pods, right? Just do one thing. Delete one of the pod. KC delete pod this and let us see. So pod is getting deleted and you know you have two pods. So one pod you are deleting, another pod again, it can be keep running. So your application will be able to connect to your environment as well. So it's taking few seconds to delete. Meanwhile, let us check here KC get pods. And if you see, this pod is terminating and new pod is already um, running last 1 minute. So if you go inside this pod now, KC exec hyphen it this hyphen hyphen slash bin slash bash. And if you type env, let us see what happens. So test config value at real time. Now, since your application is pointing to service is pointing to two pod, right? Because if you see here, you have a service which is pointing, of course, to your Node.js applications. But if you have two pods, one pod is restarted now and one pod is running 5 minutes ago. Let us try to refresh your applications and see what is happening. So you see, it is pointing because right now traffic is going there. If you keep refreshing, it is stored in the cache, but by logic, what happened? Your application already pointing. So it's why it is happening like this. One time you are getting this message and another time the different config map message because one of the pod is auto restarted, but still the connections which is using the another pod which you have not started, that is still having the old config map value. The moment I restart my another pod, this config map value will be disappeared and only the real-time config map value will be available here. I hope you guys understood this conceptually. In case you have any doubts, let me know through the comment sections. Thank you so much, guys, for giving your valuable time. Have a wonderful day ahead.